because in 2023 they changed the home interface page. So to get this default template, you will open Autodesk Inventor, and from Tools, and here from Application Options, if you open Application Options, you will get this dialog box, and from File here, you will find default templates. So you will get this form, which was included in the home page. Now you can change the default setting for the measurement units from inches to millimeter, and the standard default drawing. You can select one of those. Okay, now let's go back to presentation of today, and inshallah we will discuss the next points, which they are creating 3D shapes using 2D sketch. We will learn how to use the Extrude feature, Revolve feature, Loft, Sweep, Rip, Coil, and many other features, and modifying features like pattern, circular pattern, mirror, all of that. And we will make some examples. The first feature we will deal with it, which is the Extrude. Before making an Extrude, we should have a sketch. So we will make a sketch and discuss the all available orders in the form of Extrude. Now let's create a new project. As we discussed yesterday, we should have a project. So from the Projects tab, let's create a new project. So from here, let's select single user project and define the name of this project as Day2. And from here, let's select a location for that. So let's put it on the desktop, add backslash, and create a new folder with the name of Day2. Now, if we click finish, Autodesk Inventor will tell you that this path does not exist and it will be created. So let's click on OK, and now you can figure that we are on this project right now because we have this sign here. So if you come back to the desktop, you will find this folder, which is Day2. Okay, now let's create the first part. From here, let's open a new part from the quick access part, and let's create a new sketch. So from start 2D sketch, when you click on it, you will get the main, the origin planes. Let's select this plane, which is XY plane. And from here, let's create a sketch. So let's define this length as 50 millimeters. After that, define this height as 20 millimeters. Here, 5 millimeters. And 8. Make this line takes an angle. After that, let's make an arc like that, another line, and another line. Now let's use some of constraints. Let's select this line, that one, and make them equal by using equal constraint. So now that value and that value will equals 5. And let's select that line, that one, and make them equal. So both of them will be 8 millimeters. Select those lines and make them equal, so the angles will be the same. Now we need to define the radius of this one. So let's make it 20 millimeters. Now you can figure that the sketch completely fixed. You can figure that on the status bar. If you take a look here at the bottom, you will find fully constrained. That means that this sketch will not be moved anywhere because all dimensions and constraints make the degree of freedom for this sketch equal 0. Okay, now let's use the first feature, which is Extrude. You can move directly to the 3D model tab, okay, and you will find here some features that you can use, and we will start with Extrude feature. You can finish the sketch, or you can select the Extrude. If we click the finish, you will come back to this view, and when you select Extrude, automatically Autodesk Inventor will select the closed area. we'll select the closed sketch. Okay, and at top here, you can change between two important things. If you would like to make a solid, just to keep this icon as it is. But if you would like to make a surfaces, if you click on it, you can figure that this body will change to surfaces. If we click OK like that, you will find it's just a surfaces, no solid body. Sometimes you may need to make a surface to use it to make a rebad or something like that, and we will discuss that inshallah on the next session inshallah. We will discuss how to make a sheet metal and how we can make a rebads, common rebads. All of that inshallah we can discuss it on the next session, but here I'm make a hint for the surfaces, how you can make a surface by using Extrude. Here let's keep it as a solid, and from here automatically Autodesk Inventor select the profile. If you would like to remove the profile and select another profile, just by control and select the area. Now no profile selected, and you will need to select the profile again. So from here, when you comes inside this closed sketch, when you click, you will select this feature again. Okay, now let's discuss the second information here for behavior. From this dialog, this text box, we will discuss it. But before discussing it, let's discuss the behavior of this extrude. As you can see, you can make this extrude on the positive direction from the plane. Here we create this sketch over the XY plane. If we make it visible, here we have that plane. If you click on extrude, you can figure that the extrude direction will be in the positive direction from the plane. Okay, and if you would like to make it on the other direction, just click on flipped to make the extrude on the negative direction of plane. By that way, there are two more options. One of them is equal or symmetric extrude. So when you click on that one, you will get that value, which is distance. By the way, if you make it 50, you will get 25 on the left side and 25 to the right side, on the positive and the negative direction from the plane. If you click on the asymmetric checkbox, you will be able to define each one separately. So if you can make the direction on the positive direction by, let's say, 10 millimeters, and on the other side, which is negative direction, as 20 millimeters. So here from the behavior, you can make some important selections for the direction of the extrude. Now let's move to advanced properties. Here, if you would like to make a taper, let's make it on one direction and discuss the taper. Here you can make a tapered angle. We take a look view from here. If you make it with 3 degrees, for example, let's make it 10. Figure that out. You can figure that it will increase with a 10 degrees. You will make extrude with a tapered angle with that value, and you can flip it by clicking on that button, so it will get a negative value. So you can make a taper like that with 10 degrees. If you take a look from the front view, you can make a taper like that for this part. Okay, let's make it asymmetric to get two different values. So here you will find an option to make that one with you can make a tapered from the two sides. Let's make it 5 degrees only. Okay, like that. So you can make a taper for the positive direction and for negative direction, and already you have two different distances like that. Okay, I think that's very good options for the extrude and will help you in many different things. Now let's make it symmetric and without any taper. Okay, so we will get this feature like that and make the distance as 20 millimeters and click on OK. Now we have this feature by using the extrude. Let's make this plane invisible, so you can select it from here, and from this shortcut menu you can select visibility, or directly from the origin planes. Here you can select it from the list and make it visible. unvisible. Now you can figure that we have here a sketch and feature called extrude for the first part. So this tree includes the information of this part. All features, all sketches that you create, all work planes, work axes, everything will be stored here in this tree. So anytime you would like to modify, you will come back to this tree and select the required feature or sketch and modify it. For example, here, if you would like to modify the extrude value, just by double clicking on this feature, you will get this form again, or you can right click and edit feature, you will get the same form. And from here, you can define the direction or taper. You can define anything from this value again. Okay. And by the way, here you will find under this feature the sketch which used to create this feature. So if you would like to modify in the sketch itself, you just by double clicking on it, and from here you can define the value and increase this value, for example, like that, 20 millimeters, like that. So by that way, you can change the sketch and modify it. So if you click on finish, automatically the 3D of which depends on this sketch will change automatically. Now let's make and learn how to make a plane parallel to another surface. And this surface should be a plane, by the way. So by using a plane common plane order from here, we will select this surface with drag and move. When you make a drag and move like that, you will make a parallel plane from this surface. And you can define the value. Let's make a value with 20 millimeters. Now we have another plane. We can use it for sketching. So let's select this plane from the drawing area, or you can select it from the tree. If you take a look to the tree, you can figure that you have a new plane here or work plane here. You can select it and create a new sketch. When you click on sketch, automatically you will move to the level of detail of sketching. Now let's draw a circle and make this circle aligned to this point on vertical. Define the diameter of this one. Define the offset from here to there as, let's say, 15 millimeters. Now let's click finish sketch, and here we have a new feature for a new sketch. You can figure that here we have a new sketch over this work plane. Anytime, for example, you would like to change the location of this work plane, just double click on this plane like that, and you will get this form. You can change the plane location and the sketch location will change. So this tree will give you the ability to make an axis for each feature and each sketch that you did. Now let's make another extrude for this circle. So from extrude form, let's select this surface, this circle. Automatically, as mentioned, Autodesk Inventor will select the closed sketch. Here you can figure that the default direction here, select the positive direction from the plans that we did here and the default value. But we want to define another thing. For example, we wanted to make this part goes to the other side, okay, without calculating this one. Let's say the default value was 5, but you would like to make it extrude to the first face of the previous part. So if you click on to next, automatically SEG will detect where is the nearest surface and make extrude to it. Okay, so we will make extrude to the near surface for that one. But if you would like to make an extrude from one surface to another surface, so you have this sketch on that plane, but you would like to make this extrude from that surface, okay, to that surface. So let's select 2 from here. So you can make an extrude by using outside the sketch and make an extrude from a surface to another surface. So you will need to define, first thing you will need to define the close the sketch first. After that, you will need to define the start plane. So, for example, let's select that one. So from here, we discussed that we will come back to this order, which is from. So you can make this extrude from here, K2. So you will select this icon to make this extrude from this one to that one. Okay, you will get this extrude from here to there. And during that, you will find here some options for the extrude directions, or if you would like to get the minimum solution. As a default, that's the minimum solution because you have here a circular surface. If we make a sketch here and make a project for this arc, you can figure that you have a circle here. And let's come back to make an extrude. But that time, Autodesk Inventor will find the two closed sketches. So in that case, Autodesk Inventor will not select anything. You should select that one, and let's make the same steps from here to there. Okay, and you will find that that's the minimum solution, which is give you the minimum distance for this extrude. But if you remove this button, which is minimum solution, you will get the maximum solution, which is the contact between this extrude up to the end of this surface. You can figure that this extrude will come to the end of this surface. So the minimum solution is the default. So you can make extrude by that way by using the this extrude. Okay. Okay. Now we make a solid part. So we discuss all features here, which is selecting a profile, selecting a face from to, and selecting the discuss the behavior, which is positive direction, negative direction, and all of that. And here this tab appears. If we come back again, if we have the first sketch, you will not get this output, which is those features. Those features give you the ability to make an extrude, a solid part, like what we did here. If we select this one, so you can make a solid part like that, or you can make it as a cut. So you can make a cut on the part like that. So if we make cut through all, that one is through all, so you will make a cut by using this sketch like that. Okay, so this, the first one, creating a solid, so you will join a solid with another solid. That one you will make a cut by using this sketch, and that one will make the intersect between the solids. So if you select this one, you will get the intersect between the solids like that. Okay, and that one will give you a new solid. So if you selected that one, and let's define the value of this one like that. Here on the tree, you will find two different solids. So you can give that one a different property rather than that one. Okay, now let's make an extrude, and by using that, you can make cut through all. And before that, let's select the feature. So by that way, you can make a cut on the model like that. Okay, now we discuss all features of the extrude on that one, and now let's go to the next feature, which is Revolve. Okay, the first, let's make a sketch. So let's go this one and create a new part. And from here, let's select this plane, select create a center line. Okay, let's select this one, that one, and make them equal. Okay, make that value 2 millimeters. Convert those lines to construction lines. That one to a center line. Define the height. the diameter here. When you make a center line, and if you would you refer it as a center line, you will get the diameter. So let's define the diameter. That one will be 2 millimeters, like that one. Now we have this sketch. Okay, and by using Revolve feature, automatically when you click on Revolve, Autodesk Inventor figures that you have a closed sketch and you have a center line. Automatically make this revolve by that way. But if you would like to to remove the solid, just select this area and remove the axe. Now you will need to define both of them. By as we discussed, you can make it as a surface or as a solid. And we discussed that we will need the surfaces in the next steps, inshallah. But right now we will need to learn how to make a solids. So from here, let's select the profile. So you can select the closed area from here. After that, you can select the axis of rotation. So you will get the feature like that as a revolve. And by the way, you can use this arrow here to define the orientation angle like that, or the direction on the positive or negative direction like that. Okay, and define the value. So let's make this value as 90 degree. You can make it on positive direction or negative direction. You can make it symmetric. So if you take a look from the top view, that angle will be divided 45 degrees above and below this plane, like that. Or you can divide asymmetric values, so you can make the rotation in one direction differ from the other. Okay, so those are the features of the Revolve. And now let's create a new Revolve feature. So to save the time, we have already those samples already uploaded on Mediafire, and after this session, inshallah, I will share it with you to repeat making those orders again to catch the orders, inshallah. Now let's discuss other options on Revolve. And from here, automatically, as mentioned, when we open the Revolve, Autodesk Inventor detects that we have a closed sketch here, which is that sketch, and we have a center line there. Okay, we have this feature like that. And automatically, when you click on Revolve, you will get that one. Okay. Now, if you would like to make that surface start from one plane to another plane without defining an angle. Okay, so here the angle will be calculated automatically. So here, when you select those surfaces, you will get this area, and you can make that as a maximum solution instead of minimum solution. You can extend that from this, the extension of this plane, to the next plane like that, or you can make it on the other side like that. And if you can flip the selection, so you can delete that one, and from here you can select the start plane from here to there. Sorry, let's flip it. So from here and select that one by that way. Okay, and you can make a revolve. Sorry, I select extrude. So you can make a revolve by selecting from 2 like that. Okay, so you will get a revolve, and automatically the angle will be calculated automatically by that way. And you can make the minimum solution or another solutions like that to define the direction of the revolve. You can make this revolve as a cut. So if we make a revolve and make it complete, you can make it as a cut. So you will get this feature like that. You will make a cut on the previous solid, or you can make it as intersect. So you will get the intersect area between the two solids. So you will keep the intersect area between the two solids like that. Okay, so now we discuss the all available features on Revolve. As mentioned, you can make a solid or a surface from this icon at the top. Now let's go to the next feature, which is hole. Okay, now let's make a new part and like that, and discuss the available options for the whole order. Now let's create a new part. Select this plane, for example, and from here let's create that one. Millimeters, and make extrude. If you select extrude from here, give a value with 20 millimeters. Select this surface. Now you have a plane here. You will select it and create a new sketch. Then let's draw a circle. So define the location of this one. Like that. Okay. Convert those lines to construction lines. Define the diameter of this circle. Click finish. Make another extrude for this one like that. Now we have this two solids. Okay, two features. One extrude for this rectangle and another one for this cylinder. And now we want to discuss the whole order. So if you click on whole, you will get this form. From this form, let's discuss the first option to select the surface. So from here, you will select the surface of the hole, and you can figure that the hole comes out here. But if you would like to make it centered to this surface, just select this surface or that circle like that. And in the next step, the hole will be centered with that one. And here you can define the hole diameter. Okay, so by that way, you can make a hole. So the steps again, select the hole. After that, define the surface of this hole. After the third step, select the center line. So this hole will be centered with that face. And from here, you will define the hole diameter. Okay, some other options for the behavior. If you would like to define the distance for this hole, now the default option is through all. Through all, that means the hole will be along the solid. So it will be as a cut along the solid. But if you would like to define the distance for this hole, you can define the here you will get this sketch, and you can define the projection of this one. So let's make it 25 millimeters the length, okay, like that, and define the diameter of this one, 8 millimeters. And here you have a tapered angle at the bottom, and you can control this tapered angle. You can make it 90 degrees, for example, and you can make it as a flat like that. So you can make this one as a flat or with a tapered angle like that. So from the behavior, you can change the direction of the hole. If you have another solid on the other direction, you can flip the direction, so the hole will be on the other direction. But we don't have a solid on this area to make a cut. So if you click on OK, you will get an error because no solid to make a cut. So if you make like that, you will get an error because no solids on that direction. So click cancel, and again select hole, define this surface, and select the center line to adjust this hole on the center. Okay, so you will get this hole in that direction. Now, if you would like to change the type of this hole, now this hole without any threads or any slots, so you will find here different options if you would like to make a threaded hole or a tapered hole. So when you select, for example, a tapered hole, you will be able to select the standard of this hole. So that's the ANSI metric file. That's the standard, and you can define the direction of this hole, define the size, designation, and class, and you can make it with right direction thread or left direction thread, and you can make it with a full depth, so the thread will be with a full depth. Now, if you remove this checkbox, which is full depth, you will get the ability to define the depth of the thread here on this sketch. Now, let's click on OK, and you can figure that you have a thread on this hole, not to the end, it's with 16 millimeters. Anytime you would like to make a modification on this one, just double click on the hole and you will get this form again, and you can make the modification like changing the depth, changing the angle, the thread length, or the hole designation and hole thread information. Okay, so that's the first option to define the hole. Let's make another hole. By using the hole feature, you will get that. And if you would like to make a hole on this surface, just add the center point. After that, you can define the location of this one referred to one of those edges. So let's select this edge, and now you will be able to define the offset from here and select the other edge to define it as 25, for example. So you will get this hole on that direction like that. Now you can figure that you can minimize the hole, and let's change the thread. You can so it's interactive commands here. You can change it from here or from there, and you will get the values on that side, so you can adjust it like that from here. So you have here another thread hole like that on that surface. Let's click on OK, and now we have the first way by defining the hole on a circular surface by selecting the face. After that, selecting the circular face to define the center of the hole, or by selecting a face and selecting the reference lines for this hole. Now let's make a sketch over this plane, and let's add some nodes here and there. Okay, and you can define dimensions for those holes, and from holes you automatically Autodesk Inventor detect a location of a new holes or those points. Okay, I think you remember that we discussed that we will use the point option or the point order in sketching when we this point on the previous session. We discussed that we can use it for the tube sheet holing, okay, because those holes will give us the ability to detect the allocation of the hole. So here we make some points like that, and when you click finish, after opening the hole form, automatically it will detect the location of holes. If you would like to remove one of them, just click on Control button and select the hole. If you would like to add, just select the hole like that. Okay, now that's another way to make holes on a surface. So let's click on OK to add those holes by that way. And now let's know one more order regarding the axis. We will discuss it in detail, inshallah. But here, that's the ways to draw an axe. One of them is making an axe passing through 2 points. So if we select this point, for example, and that point, so you can figure that we have that axe here, go through those 2 points. So we create that axe by that way, and you configure that all features stored here on the memory or on the tree of this part. So if we add a point at the end here, so we can use this point as a start point of the hole. So if you click on hole, and from select option, we will select this hole, okay, like that, and you can select the direction. So let's select the direction, which is the X. So you can make a hole on that direction. We need to flip the direction of this hole. So the behavior of form, we can reverse the direction of the hole to make the hole on that direction, or you can move it manually. So if we make it as a straight hole only without any thread, you can move the direction of the hole along the way that you would like. And as discussed, you can change the direction. So if you would like to make this hole along that edge, you can make it like that, or you can make it using working axis like that. So you can change the direction of the hole, select that direction like that, and you can flip it by this arrow, or flip it by using the flip direction from here. So those are the available ways to generate a hole. So let's discuss them again quickly. First one, by selecting a face and defining the circular surface to make this hole at the center of the axis of this radial surface. By selecting a face and define the location from two edges. So here we define that one as a location from two edges. Third one, by defining the a sketch. This sketch include points. And the fourth one, by defining a point and select a direction to make this hole, which is that one. Okay, so those are the available features for the holing. Okay, now let's go to the next feature, which is fillet. Okay, the fillet option is a very important feature, and it's include many different options, and inshallah we will discuss it. Let's create a new part, and let's create sketch. From here, let's make this rectangle, and let's weld this point to the center point, make this line as a construction line, get an arc, and make arc like that from here to there. Define the width, let's make it 20, and that 40 millimeter, and let's click finish. Let's make it extrude and 20 millimeters. Okay, now let's discuss the fillet features. When you open the fillet form, you will find here edge fillet, which is a default option, and here we will discuss the fillet options. After that, we will discuss the face fillet and full round fillet. So from here, edge fillet, you can define the size of the fillet. So let's make it 5 millimeters, for example. And from here, that's the selection mode. You can select separate edges like that. Okay. Or you can, if you would like to remove the selected edge, from Control button, just select the edge again to remove it. Or by selecting a loop. So when you select this one, you will be able to select all the loop like that as a closed chain. So let's remove it again. Or all features. So you have a feature here, this feature called Extrude. So when you select it, automatically you will make a fillet for all edges of this feature. Okay, by that way. Okay, now let's discuss another thing regarding the constant fillet. For here, if we select this edge and we have this this fillet along that edge, we can make a variable fillet. So if you make a fillet and select this edge, for example, you can define a start radius and end radius. So from here, if you take a look at that one, that's the start radius. You can make it 5, but the end radius, let's make it 10 millimeters. So if you take a look from the back view, you can make the radius at the start of this edge start at 5, and it will be increased up to reach 10 millimeters at the end. Okay, it's not only like that. You can make another different radiuses or fillet values along the path. Here, if you click on this form and select a node here, for example, at the middle here, you can define the location of this as a percentage of the length of this selected line. So you can make the fillet here at this one as 2 millimeters. You can figure that you create a different fillet value. So start at 5. After that, here on this point, the value will be 2 millimeters. After that, it will increase from 2 up to 10 to the end. Now you would like to make another fillet here at the middle of this line. So if you click here on this form and select that value, you can let's make it on the middle of the arc. So, and you can make the value at this point. Let's make it as 2 millimeters at this point. So from here to there, it will be 2 millimeters, or you can increase it, let's say, up to, let's say, 8 millimeters. So you will get an 8 millimeters at this point. It will be like that. So from 2 to 8. And let's add another point at the middle here and make it as 2 millimeters. Okay, you can figure that you make a variable fillet values start at 2, start at 5, 2 here, and 8 at the middle, and another 2 at this point. After that, end at 10. So something like that, you can use it if you make a tool and you need to make a handling by hand. It will be catched by hand. So you can make a different fillets for your fingers. If you would like to make a tool, you can catch it by hand. You can make or use the different value feature. So let's come back to the 3D model and create another type of fillet. If you select the corners, for example, if you have those 3 corners like that, and let's define this value as 2. Okay, and if you come back to setback give you the ability to change the here you can figure that the end of the end of this the intersect between the 3 edges give you this result. And if you would like to move this fillet here back up to another value, so you can select the edges like that. So we will select this this point and define the back offset for each edge. So from here we move this one back here, and that one, let's make it 10, and that one is 15. So you can figure that if you take a look from here to there, from this view, you can figure that you make this fillet or this intersect between the 3 edges, move from that side to 5 and from here to 15. If you take a look from the top, it's from 15 here and 10 there. If you take a look to that one, you will be able to make a fillet with that tape, 5 offset from the edge here and 10 on that edge. So by using this order, which is setback, you can modify the setback configuration of the intersect of the surfaces at the end point here. Okay, now we discuss the available features for the fillet on the first piece, which is edge fillet. And now we have two more options for the full round fillet and face fillet. Okay, let's open a new sample. Okay, let's open that one. Okay, and for here you can figure that we have this shape, and by using the fillet, the third option which is full round, you will make a fillet between three surfaces. So you can select that surface as a loop. You can figure that. Here, when you select the third one, automatically the fillet comes through the three surfaces. Okay, by like that. Let's make it again. So from here, fillet, and select full round fillet. So select that one, and that one. Automatically, you will get a full round fillet. So you will need to select three chain surfaces. They should be connected to each other. So you will get this fillet by that way. Now, another feature, we can use it if we have those two features like that. There is another option to connect a fillet, to connect between those bodies with a fillet. Here for the that type, which is face fillet, if you select that face and select that face, you will be able to make a fillet between them, and you can define the value between them with a fillet, millimeters like that. So it's very difficult to make something like that by using the other features, but by using the face fillet on the fillet order, you can make that one easily. So you can connect the faces by fillets like that by using the face fillet order. Okay, now, so we discuss the features of the fillet. Here we discuss edge fillet, we discuss the constant fillet, variable fillet, and sit back. And from here, discuss the full round and the face fillet. Okay, now let's go to the next feature. So we discuss the face fillet and the round fillet. And from here, we discuss the face fillet and round fillet. Okay, let's make or use the chamfer options and discuss the chamfer options. Let's open a new part or prepared part. Okay, let's open that one. And from chamfer, let's open this form, and you will get that form. As discussed in the 2D chamfer, we have three different types. Make the distance equal. So when you select that one, you can make this chamfer equal. So that value will equal that value. Okay. And if you select a chamfer by that one, before discussing that, you can make this one as a chain. So all tangent connected edges, so from edge chain, when you select an edge and this edge with another tangent edges, it will select it as a chain like that. Okay, but if you would like to select a single line, so from here select single, so you will be able to select a single lines like that. Okay. Okay. Now let's discuss the other types of chamfer. So the first line with equal values. The second one, you can define a distance and angle. So you will need to select a face and edge. So again, so from here, if you select the second one, you will need to select a face, okay, and select an edge. So if you defined that value, so the distance, which is 2 millimeters, will be on that face, and the angle will be from the end of that point like that. So the value of 2 millimeters will be from here there, and the angle will be 20 degrees from this point along that one. Okay, so that's the second type of chamfer. Or the third type, which is making two different distances. So if you select this edge, you can make that one with 2 millimeters and 1 millimeter. And if you would like to flip the values just from this button, you can flip the values like that. So here, that's the chamfer. So by clicking on flip, you will be able to flip the direction. And instead of changing the values here, by using this button, the values will be changed, distance 1 and distance 2. Okay, let's discuss some other options for the chamfer. Here, if we if we select this edge, for example, okay, and make it equal, and from here you can select a start point for the this chamfer. So we will make this chamfer start from the end by selecting a value here. So you can define this value, make it start at 10 millimeters. For that, you can make that's the end, and you can make it again with the start. So you can change the value. So you can make a chamfer in a certain area along the line, not along all the line, but on a defined length. So you can define it from start and end the chamfer. So by that way, you can make a chamfer not along the edge, but on a defined length along the line, not all the line. Okay, let's discuss another option for the chamfer. If we have 3 edges like those here, we have the end of this chamfer, which is the intersect between the faces. You can change the setback configuration. Here, the result give you a new surface. So the intersect between the 3 surfaces, here you have first surface, second surface, and third surface along each edge, you will get another face. If you would like to change this setback and make it no setback, you will get just a point, which is 3 lines, and a single point here, which is the intersect between the 3 surfaces. So let's check that again. So the setback, that's without the setback, but if you select that one, that will be the setback configuration. Okay. Okay. Now we discuss the available features for the chamfer. So here we discuss the chamfer types and setback, and discuss the chain, and from here discuss the start and end options. Now let's discuss the shell order. Let's open another part, rebuild part. Okay, and when you select a shell command from here, automatically you can figure that if we make it as a wireframe with hidden edges and make this value 4, you can figure that you make this feature empty from inside with that thickness. Okay, to make it appear a little bit, let's make it shaded. But in that time, I will select that surface to show you. We remove that surface, and you can figure that you make a shell, which is you make this body from inside as an empty solid with a thickness with that value, which is this thickness. Okay, so you can make, if you take a look at the top from here, the first selection here that will keep the inside, the outside the value. So if you select shell again, and let's remove this face. Okay, you can figure that with that one, you will move the shell to the inside. So you will move the walls with 4 millimeters to inside. But if you click on that one, you will keep the outside surface and make the thickness to the outside. So let's compare that. That's we will keep the outside surfaces as they are and move the thickness to inside. But here, if you select that one, you will keep the outside surface and make the thickness to the outside. And from here, you can make it at the middle. So here we have this shell like that. And by changing the value from here, you can increase the thickness. So if you take a look from back here, you can figure that you keep all surfaces as they are and give a thickness for everything. Now, if you would like to remove another face like that face, so it will give you that result. So we remove the top face and that face to get that result. Now, some other more options here for that, like if you would like to give one of those faces another different thickness. So if we select this face, for example, and define the value, let's select this one and define this value as 20 millimeters. So you can figure that to give a different thickness for this wall with 20 millimeters, but all the other still 10 millimeters like that. Let's select another wall, and by clicking on add, and let's select this one and make the thickness of this one as 30 millimeters. You can figure that you give a different wall thickness for those features. Okay, so those are the available features for the shell options. And let's go to the next one, which is the draft. And let's remove this face, that face, to show you another option for the draft. Here we discuss the shell options, and for the draft, we will discuss the draft option and how you can make a draft surface. Actually, this feature important for the casting industry, because they are making a patterns. Those patterns should comes out from the mold after putting a sand. So the surface should include a draft angle to get it out from the sand easily without breaking the sand surfaces during the making the mold before putting the molten metal inside the mold. Okay, now let's select a surface. Okay, after that, let's select some faces. So let's select that face. Okay, let's remove this and select face at the top. And the same here. So you can figure that you can make a drafted surface. So you can make this surface drafted like that. So it's easily you can move it out from the sand by that way, and you can select another faces like that. So you select faces like that, so you can make a draft for those faces during creation. Okay, now let's go to the next feature, which is thread feature. It looks like the type of thread here. It looks like the type in holes. You will need to select a thread designation and size type. Okay, so let's open that part. Okay, and from thread, you will get this form. Let's make an outside thread. Let's start with outside thread. So from here, if we select the outside surface like that, you will get a thread over the outside surface of this cylinder. And from here, you can define the type of the thread, define the standard or size, define the designation and class. You can make the thread on the right side or on the left side. Okay, and that's the depth of the thread. So if you, let's make it 50 millimeters, you can figure that the thread comes from the bottom here. So let's remove the surface and make it start from top. So when you come near to the top here, so the thread will start from the top like that. And you can make it with an offset from the start. So you make it with an offset, so it will the length of this thread will be 50 millimeters, and with an offset 10 millimeters from the area that you select. And if you select that, it will be with a full depth. So the thread will be along the surface. But if you would like to define the value of this one and make it offset, let's say at 0, so it will start at from 0 with a length 50 millimeters, or you can define the offset like that. So we have a thread along this one from the outside. Now let's add another thread, but to the inside. So when you select this surface, the same thing, you will be able to define the standard or the type, the size, designation, class, and direction, and you will be able to make it through all or define a value. So let's make it with millimeters and with offset 20 millimeters like that. So you will get an offset for this thread along from the start point. So by that way, you can make a thread along cylindrical shapes. Let's go to the next orders. They are the working planes, working axis, and work points. The using of work planes is very important because it will give you the ability to make a new plan, to use it to create a new sketch. Okay, there are different ways to generate it. Like if you would like to make a plan parallel to another plan, but with a distance. That's the first one, which is making a plan to another plan with equal or with a defined distance. So let's open this one, this model. So if you select this plan, which is plan offset from another plan, or you can select a general one, and by selecting this surface and drag and move like that, you will make a parallel plan for this face with a defined value. So you can define the offset between that and the from inspect tool. For example, if you open inspect and select measure tool, if you would like to measure the distance from here to there, you can figure that it's 50 millimeters here. That's the distance between the plan and this surface. Okay, as discussed before, all features will be stored here with the sketches. So if you would like to make any modification anytime, you will come back to the tree and modify your feature. So that's the first feature, which is making a plan from a point and parallel to parallel to another plan with a distance. Now let's make a plan go through a point and parallel to another plan. So here, if we come back to that one and select parallel to a plan and passing through a point. So if we select this point, for example, and select this surface, you can figure that we create a new plan here, passing through this point and parallel to that plan, like that. If we take a look from the top view, here we have that plan passing through this point and including this point and parallel to that plan here. Okay, another type of plan, which is a plan to the mid of spacing. So this option, you can use it in case if you would like to make a mid plane. So you would like to get to create a plane on the middle distance between that surface, okay, and that surface. So automatically you will get a mid plane at the middle here, on the middle distance between those surfaces. They shouldn't be parallel. For example, you have this plan not this surface not parallel to the one here. So if you select that one and that one, you will get a plan with the same angle from, if you measure the angle from here to there, it will be the same from here to there. So let's measure that. So from measure, you can measure the distance, the angle from here to there. So it's 22.5. So from this plane from to that one, and if you measure it from here to there, it's 22.5. So they shouldn't be parallel if you would like to make a mid plane. Okay. Now let's make those planes invisible. So let's come back to the next one, which is middle to towards. If you there are some features. If you have a ring, let's make something like sorry, this part. If we have a center line like that, and have a circle here, and if you make a revolve, if you have something like a donut like that, so if you make a mid plane for this one, you will divide or make a mid plane for this one. If you change the color, visible like that, so you can figure that you can make a plane dividing this one or this part like that. Okay. The next one, make an angle to plane around an edge. So for example, if you would like to make a plane go through this or including this edge, but taking a value or a tilting angle with that plane. So if you select this plane, you will be able to make another plane. Here you can figure that you can make another plane including this edge and an angle between that face and this plane. So you can define that value as 20 millimeters. So you will get a work plane going through this edge, and you can define the angle of this one by that way. Okay, that's another way to generate a work plane. Another one, which is making a plane going through 3 points. So to define the plane, you can define the 3 points. The 3 points, they are enough to define the plane. For example, if you select this one, by the way, if you select a general, the general one, you can do anything with those. So the general one gives you the ability to make any one of those. So let's select 3 points and select that one, and that one. You can figure that you create a plane going through that point, and that point, because 3 points can create a surface. Okay, so this plane will go through those lines like that. Okay, another one, which is plane going through coplanar edges. They should be coplanar. Okay, like here, if we open from that part, if you try to select this edge and that one, okay, those are parallel edges. So when you select them, you can get a plan through them. But let's try another one by selecting that one. So let's select this edge and try to select the edge at the bottom here. You will not be able to select it. If you try to select it, you will not be able to select it because those edges are not on the same plane. Okay, another one. If you try to select a point, for example, if you try to select another edge, like that, should be you can get this plane. Okay, so here we finish the above types of working planes, and here if you have a tangent, you can make a tangent plane to a surface through an edge. So from here, let's make this invisible. So you can make, if you select this face, for example, and select that surface, so you will make a tangent plane parallel to another plane to this surface. Let's try it with another inclined plane like that one, and let's select this one. So you can create a parallel plane and perpendicular to the round surface. Okay, so if you have a line or a point, like if we have, let's remove those, if we have a work point here, okay, like that, so you can a work plane for that through this point, so you can make a tangent plane through a point and a tangent to a surface. Okay. Normal to an X. So if you have a point, let's make work plane here. So if you have a point at the middle, so you can make a plane goes through this point and parallel to that one, like that. Okay, so you will find different ways to define the planes. And if we have a sketch, for example, and that one is very important one. If you have, let's say, a line here, like that, you can create a plan perpendicular to that line at the end. If you select this line and select the end point, you will be able to generate plan perpendicular to that line at the end of this line. Okay, that's one of the important types of the working planes, which is normal to a curve at a point. By the way, that one could be a line or a spline or arc. So if we make an arc like that, so if you create this arc and select the end of that one, you will be able to create a work plan perpendicular to this at the end of this arc at this point. Okay, now let's discuss the working planes, working axis. So from here, if you open that one, you can make this axis along the edge. So if you select an edge, you will be able to define a center line along this edge, or you can make it through a hole and coming through a hole and an edge, or 2 points. So if you select this point and that point, you will be able to generate an axis goes through 2 points. So 2 points give you the ability to draw a line. So the extension of this line will be an axis. Another one which is intersect between 2 planes. So if you select that plane, for example, with that plane, the intersect between them will give you this X, like that. Another way to create an X, which is normal to plane through a point. So from this one and select this plane, you will get a perpendicular X along a point and perpendicular to a plane, which is that one. And if you have a center point or a center line, if you have an ellipse or like that, so ellipse or, so if you have an ellipse or a cylindrical shape, so if you have a cylindrical shape, just select the cylindrical shape and you will get an X along the center of this one. Okay. Another features for the point, you can make a ground point, which is a fixed point. It will not change during the movement of the feature. You can add a vertex at the edge, fixed edge. And if you have a chamfer, for example, if we make that 110 millimeters, you can make a point at the intersect between surfaces. So if you select this one, that one, and that one, you will get a work point at the intersect of the three planes. A point parallel to located on a plan and with an edge. So if we select this plan and select this edge, you can add a point at the end of this one. Another type, which is a center point to a face. If you select this face, for example, you will get a point at the middle. And the same if you have a sphere or tool, you can add a center point to this sphere or this tool, like what we did on the other example for the work plane. Okay, so here we discussed the available features for the work plane, axis, and work point. Let's go to the next modifying features, which is rectangular pattern. Okay, so from here, let's close this one. And let's open the rectangular pattern. So let's come back here and open that one. Okay, we have this 3D model. Here from the rectangular pattern, if you select this one, you will be able to select a feature or a solid. So you select this feature, you can select it from the drawing area, or you can select it from the tree. So it's the same. From here, you can select the first direction. So like that. So that's the first direction. And you can figure that the direction of the arrow goes outside. So to flip it, you can make it by clicking on flip button to flip the direction. So let's make it 5 parts. And you can define the spacing between them like that. And if you would like to make it the original feature, make it on the middle, just click on that button, and that will give you the ability to make them symmetric. So half of the number of patterns will be on the right, and another half will be on the left. So the original one will be on the middle. So if you remove that, you can control all the direction, left or right, like that. Or by clicking on that button, which is mid plane, it will give you the ability to make this feature on the middle of the pattern. Okay, so let's make it like that. And you can make another direction by that way. So if you make it 3 and make that 115, take a look from the top view, you will get this array. So let's increase this one 6 like that. So you will get this array. If you click on OK, you will get that pattern. That's regarding the rectangular pattern. Another option for the rectangular pattern, if we have this. We have this part by using sweep order, and we will discuss how we can use the sweep order on the next slides. But we have here this feature for that one, and we want to make a pattern for this one. So if you select this feature and select here the boss, and the boss will be this sketch. So we will select this sketch to create the boss and define the number of, let's make them 20 parts, and the spacing between them, let's change it to be along the curve. So along the curve, so the number of holes will be along the curve. But you can see that the hole will goes out from the curve. It's not suited to the curve. Here you can figure that it's not suited to the curve. To adjust that, we will open this extension, and from adjust we can change the start point. So the start point comes here, so we can change it to start at this point. So here that feature will start measuring from here, so it will be adjusted along the path by that way, and you can make it with a distance, so you can change that to be 400 like that. So you will get a pattern through path by that way. Here, after making this pattern, you can figure that we don't select this hole. So if you would like to modify the pattern again and add this feature, which is that hole, by double clicking on the feature, you can select another feature, which is the hole. So you can make those two features. If you take a look to the tree here, we select the revolve and the hole to make a pattern for them. So by that way, we made a pattern for those two features along this path. Okay, let's close this. And now we will make a circular pattern feature and discuss the available features here. If we create a new part and create a circle with, let's say, 50 millimeters diameter, finish, click extrude and make it on the symmetric plane and make it meters, and use the same plane here to make a rectangle. So from here you can make a slice graphs, and we will discuss that. You can make something like that. Find the here, increase that a little bit, fine, and finish. Now let's make extrude for that one, right and left, but let's make it 10 millimeters like that. So we have this feature by that way. So if we try to make a circular pattern, you will be able to select the feature. So you can select the feature from here or from the drawing area. You can select it from the tree or from the drawing area. So if we select it from here, for example, the second step, which is selecting an axis for rotate. So you can select a circular surface, or you can select one of origin axis. So if you select one of the origin axis, or you can select this surface like that. So you can make a circular pattern for this feature. And from here, you can change the orientation direction. You can figure that this arrow goes to counterclockwise. So if you would like to flip it on the clockwise direction by using this one. As discussed yesterday on the sketching, that will appear if you make the angle with not 360. So when you make that, you can change the direction of orientation. And if we make them 7, for example, and clicking on mid plane, you can figure that the original feature will be on the middle. Okay, so half of number will goes to right and half to left, like that. Okay, so by that way you can define the orientation of this part. One more option here, if we make it equal, regarding the orientation. Here you will rotate the main part. If you the default option, which is rotating the main part around this axis. But there is another option which is fix the main part configuration. So you can figure that this one will be parallel, keep the main part direction. So it will keep without rotating around the axis. So if you would like to make a feature like that, you will be able to make it. If you create adjust, you will get the same feature distance. So let's move adjust and keep it like that. Here, sorry, optimize, adjust and make it rotate. Here for the fitted and incremental, here, if you would like to define the angle between each segment and the other segment, you can define it from here if you select incremental instead of fitted. So the fitted, here you can define the all contact angle, so it 180. So from the first one to the last one, the angle will be 180. But if you would like to define the incremental, which is the angle between each one and the other, you can define it from here. So if you measure the angle between that one and the other one, you will get 50 degrees like that. So let's click on OK, and let's measure the angle between them. So from inspect and the measure tool, if you select this surface and that surface, the contact angle will be 15 degrees like that. That's 15 degrees. Now let's come back to the circular pattern and make them parallel to the part. So you will get that shape like that. Okay, so here we discuss the circular pattern features, and now let's discuss the rib features and how we can make ribs by using rib order. Let's close this, and here let's open this part. Okay, let's make a sketch over this plane. Make a line, click finish. Now when we click on rib order, okay, sorry. When you select the rib order and select this line, you have two different options, which is normal to sketch plane and that one. For that case, the suitable one is the parallel to sketch plane. So when you select it and select the direction of plane like that, sorry, let's modify this sketch a little bit. Finish. So let's select this rib. When you select parallel to sketch plane, you will get that one, and you can define the thickness of this rib. Let's make it 10 millimeters, like that. Okay, so you can get this rib by that way. You can flip the direction of that one here by selecting the direction. That means the rib will goes inside the solid. But if you make it on the other direction, no solid here, on the other direction, we make a print screen, like to say. If you would like to make it on that direction, okay, or that direction, okay, that's by selecting that one. So no solid on that area. So when you select that one, you will not get any preview. But if you select that one, you will get a result like that. Okay, this rib you can make it symmetric like that, or you can make it on the left side from the plane or on the right side of the plane, but we will make it as asymmetric. You can make it not a complete to the next, but you can make it finite. So you can define another value for that one. So you can make it 15. So you can make it as stiffening like that. Okay. So that's the first way to create ribs. So you can control the rib. You can make it a complete rib, which is 2 next, or you can make it finite rib like that. Okay. Now another type of ribs, you can do it by using the same form. If we open this part, you have you have this feature. You have a shell feature. If we move the end, we have this extrude feature. After that, we made a shell order. Okay, so we empty this face, and by selecting that face, we make a sketch over here. So we have this sketch. So when you select the rib feature and select the those lines like that, you will be able to make another ribs automatically. It will be to the next. Okay, and if you select the other direction, as we discussed on this image, the other direction, no solids here, so you will not get a result. But on the other direction here, you have solids, so you can make the ribs on that direction. Let's change the thickness of the ribs. Let's make it 4 millimeters, for example, like that. And you can make them as finite instead of solid, so you can define the thickness for them, or you can make it to next. If you take a look from the top view, you can make a draft for the surfaces of those ribs. So, for example, if you make a draft with 5 degrees, so you can make those ribs with a draft like that. So if you take a look from here or from top view, you can make those ribs with a draft angle to the end like that. If we take a look from here and make it wireframe with hidden edges, so the hidden edge, you can figure that the rib with a draft angle by that way. From the other view, the ribs with a draft angle. The shading comes back to shade with edges. And now let's discuss another feature. Okay, coil. How to make a coil and the ways to define the type of this coil. If you would like to define it by number of revolution or total length or something like that, let's discuss that. If we have, let's create a new part and let's draw a new sketch. And from here, let's make a center line. Compare that one to a center line. Define that as 100. Make circle with, let's say, 10 millimeters and with an offset here to there with 100. And let's make them in horizontal position. And now let's click finish. Now if you select coil, automatically the closed area will be selected. Now you will need to select the center line of the coil. When you select this center line, you will be able to, if you take a look from let's say that view, from the 3D view, you can flip the orientation. You can make it clockwise or counterclockwise like that. Okay, and flip the X direction, make it on the top or bottom. So you can figure that the coil will go to top like that. If we increase the number of revolutions, let's make them 5 right now. After that, we will discuss those options in detail. But if you change the X, you can flip the direction of this one, and you can make it clockwise or counterclockwise from the rotation right here. And you can make it as a surface or a solid, but in our case, let's keep it as a solid. And from here, you will find the different options to define the type of this coil. The first one, which is pitch and revolution. So the spacing between each cross section, you can define it from here, and the number of revolution, you can define it from that value. And by the way, you can make it tapered. So if you change this value to 5 degrees, you can figure that the coil will, let's make it 15. And you can figure that it comes like that with a tapered angle. So let's increase it a little bit, 25, and click on OK. You can figure that the coil comes like that with a tapered angle. Let's come back to the coil form, and let's make this value as 0 again. And let's change the definition of this one. We will define it as a revolution and height. So from here, you can define the height of the coil. So let's make it 150. And the number of revolutions, let's make it the number of revolutions, let's make it 10. Okay, so that's the second way to define the coil. So the first one, second one, and third one, which is pitch and height. So by that way, automatically the number of revolution will be calculated. So if we make that 100 and let's say 15, so the number of revolution will be calculated automatically like that. Another option here, which is spiral. So the spiral coil will be on the same level, So you will define the pitch and the number of revolutions, and by that way you can create the coil. So let's increase this wheel. So in that way you can make a coil as a spiral coil like that. Okay, let's make it again by that way. And from the coil end, you can make the end of the coil as a natural end, or you can make it flat end. So if you select flat end at the start, you can check that. So here it will takes an angle during going out from the plane. But if you make it flat, you can figure that it goes out as a flat line, and here you can define the transitional angle and flat angle. The same as the top, you can figure that that line is not a straight line. If you make it flat and define that as 90 degree and 90 degree, you can figure that you will get a flat angle like that. So if you click OK, you can figure that you have this coil with a flat end at the bottom and top, like that. With a 90 degree, you have a flat seat here and there at the top and the bottom. So those are the coil features and how you can deal with it by defining the type of how you what is the way that you need to define your coil information. Let's close this and let's go to the next feature, which is sweep. With a sweep feature, actually it's a very important feature. We can use it to give a path for a cross section to move. This cross section will move along this path, and there are different options for this feature. Give you the ability to make beautiful and complicated configurations. So let's open the first one for the sweep feature from here. And we have two sketches. So the sweep order needs two sketches at least. Okay, but in Extrude or Revolve or Coil or Rib, we used single sketch only. But with the sweep, you will need to make two sketches. One of them is the boss, and the second one is the cross section. So you will need to define the cross section and the boss, which this cross section will goes along it. So if we select sweep, automatically Autodesk Inventor will detect the closed area, and from here you will need to define the path of this cross section. So you will get something like that. Okay. By the way, here you can define the tapered angle. So let's make it 2 degrees. So you can figure that the tapered angle increased with 2 degrees up to the end. And if you make it with a negative value, you can get that result. So this cross section will be tapered along that path to get it to the end like that. And you can make it twisted, and we will discuss the twisting option. But before that, let's discuss the feature of fixed cross section. Let's make that one as 0. And here, with that order, which is flow path, the cross section will be perpendicular to the path along the path. So it will be perpendicular to the path up to the end. So you can figure that the end here of this one will be perpendicular to the end of this path. But if you select this one, which is fixed, the cross section will be parallel to the original sketch, and by using those dimensions, that sketch will not appear. Let's make it 45 degrees and repeat that sweep order, and let's select that path. You can figure that the end here, by selecting the full path, it will be perpendicular to the end. But if we select fixed, you can figure that this cross section will be parallel to the original one, so the end here will be parallel to the start here. So let's make it instead of fixed, let's make it follow path to get that result. Okay, now let's make it back 90 degrees, and let's make another sketch at the end instead of circle to discuss the twisted angle. So let's come back to this sketch. Let's make this circle as a work line and make a rectangle. Let's define this one as 10, that one as 15. Click finish. Now we have two sketches, this rectangle and that path. So if we select sweep and select that path, from here you can figure that if we make the tapered angle 0 and the twisted angle 0, here if we make a twisted angle like 90 degrees, so the start phase will twisted 90 degrees along the path. So here you can figure that the end phase perpendicular to that one was 90 twisted by 90 degrees. If we increase it 180, you will get that shape. So you can make complicated shapes by using sweep and twist like that. So you can make a twisting for the feature during along the path. Okay, now let's discuss another feature for sweep. If we open that one, you can figure that we have 3 sketches. As discussed, for the sweep order, at least you will need two sketches, and you can add more. But for here, let's make this sketch invisible. If we make a sweep order by selecting that cross section and the curve, you can figure that it looks like extrude order. You can make it by using extrude. It's not an issue to make it by using extrude. But the point here, which is making a guiding surface. If we make this sketch visible again, and from sweep, let's select this one and select the path. But right now, let's make a guide surface. So if you select this one, you can figure that you made a sweep for this cross section along that path, but you have a controlled guide rail along that one. So you can get this feature. You can make that feature by using the type of guide service, which is or guide line, which is that one. One more option, which is you can make scaling. Here, the default option is scaling in Y and X. Okay, so if you take a look from here, the scale on that direction. Okay, let's make a print screen to that. Here you can figure that scaling along that direction equals the scaling along that direction, which is that option. Okay, which is equal scaling. But if you would like to make a scale in one direction, which is the direction of the sketch only, so let's select that option, which X direction. You can figure that you can make a scaling along X direction only and keep the other one without scaling, like that. So you can make you can change the configuration of sweep by making it by that way, or you can make it without scaling, so it will be the same. So you will not make a change by using a rail because you remove the scaling option. So here you can use a scale in one direction or in two direction along the cross section. Okay, so that's the first way that you can use sweep. Let's check another options in sweep with another example. Let's open this one. Okay, we have a curve here along this surface here, and let's make a sketch for at this point. So let's project this point. So you can figure that we used a project feature, which is that one, to print this point here to use it for drawing. So let's make like that, and let's make it and 5. Finish. Now we have this cross section and we have a path here. So if you select sweep and select this path, you can figure that this path goes along, this cross section goes along the path without defining. If you make it like that, it will be, sorry, let's make it as a cut. So you can make it as a cut. You can figure that it goes out from the surface. The distance here are not equal at the end. You would like to make it take the contour of the outside contour of this face. So if you come back here and select a guide surface and select this surface, and when you click on OK, you can figure that this cross section will be the same. Here, if you measure, let's inspect the length. Sorry, if we measure the length of this one, okay. And the length of this one, like that, they are equal. Those edges are equal because you make the contour of this one, which is taking the surface. You can figure that it's take the contour of the surface. So it's rotated by that way because the guide surface is the outside surface of this cylinder. Okay, that's the third way to use the sweep order. Another sample, we can use it for the sweep. For example, if we have a feature like that, and let's make a circle here, create a circle at this point, define this one as 5 millimeters. This line, sorry, convert this line as a construction line, click finish. Now, if you would like to make a sweep and you haven't a path, you would like to select edges instead of path. So from here you can select path like that. So you can select this edge, that edge. Okay, so you can select edges instead of selecting a sketch. Okay, so you can make it like that by extrude. So you can make it as a cut. We come back here, you can make it as a cut or as a join part. So you can make it, as we discussed in extrude and revolve, you can make it as a solid or a cut or intersect. So with the intersect, you can get it the intersect between the two parts like that, or you can make it as a cut. So you will make a cut like that, or you can make it join solid with the previous solid like that. Okay, now we discuss the features or the available features for the sweep by this example. And in this example, we discuss the features of the parallel face or perpendicular face along the path. Here we discuss the sweep by using a guide sketch or a guide surface or an edges instead of making a path with sketch. Okay, now let's discuss the features of Loft. Okay, the Loft feature is one of the very important features for modeling. You can use it for very complicated shapes in case if you have a different sections along the path. For example, for the reducers, which they have a rectangular end and a circular end from the other side. That's an example. So for the Loft, by the Loft feature, you can connect between different sections along the path. Now let's open a sample for that. So let's open this sample. Okay, in this sample, you can figure that we have this rectangle, we have this circle, and we have a point at the end here. Okay, if we open the Loft order, so you can select a closed sketch like that and connect it with another sketch. So you can figure that those two sections now connected as a solid. By the way, as discussed, you can make it as a solid or surface. So the surface, you can use it on different purposes, but here we need it as a solid. So we connect the circle and this rectangle here, and you can connect it with a point. So you can get a complicated shape like that with different sections. So the first section is circle, the next section is rectangle, and the last section is an point. So you will get a surface like that, or a solid body like that. And you can, you can make it with a controlled guide at the outside. If we make this sketch, this outside sketch on the which connected between the three sketches from the outside, you can use it as a guide. So from here, you can make a Loft and connect between those shapes like that. But in that way, here we will select rails, a guide rail. So when you select this rail, you can figure that you change the configuration. You make this surface railed to that guide, and you can add more guides on each surface. So you can make a complicated shape, like if you have a 3D mouse, or your mouse, you can make it, you can figure that it's including from services. So you can make those surfaces by using those features by making a guide service on Loft. Okay, so you can figure that here we make a guide surface, which is that line, to control the service from that point. Let's make undo. And let's make that one invisible. And let's make a guide at the center. You can make a guide at the center of the sketches, which connect between the center of each shape, like that. So if we make a Loft and connect that one with a point, and select a guide center line, so when you select this one, you will get that shape. So all services will be guided by this center line here. Okay, so you can get a shape like that by using the Loft order. Okay, one of parts you can use the Loft options, the hook. The hook, you can figure that it's created from different sections from start to the end. So by using the Loft order, you can make a different sections and connect between them to get the hook configuration. Now let's go to another feature, which is Emboss. So the Emboss feature, you can make a text or a sketch, make it grooved inside a part with a parallel to a surface. You can make it warped to a surface. Let's take an example for that. So let's open this one. We have this circular part, and we have a plane here. Let's create a sketch over this plane, and let's make a text. increase the text. Now we have this text here. If you click finish, now you have this text over this plane, and by selecting Emboss order, you can select this text. Here you can figure that the arrow direction goes outside the plane. Here, if you click in OK, you will get an error because the solid will comes out. It will not connected to a solid. So you will need to flip the direction from here. Okay, so the solid will be on that direction. So that's the depth. If you click on OK, now you will get this text along the over the here over the cylindrical surface. But if you take a look from the top view, you can figure that all lines are perpendicular to the origin plane. You have a plane here, so all lines are perpendicular to this plane. If you would like to make it warp to face, you will need to select that option, okay, make it warp to face, and from face select that face. If you click OK, now if you take a look from the top view, the lines will be perpendicular to that surface, which is the cylindrical surface, not to the origin plane. So let's make it back. So by double clicking on this, and let's remove that one. So you can figure that the difference between, you can catch the difference between that one and the other. Okay, now let's make it grooved. Here for that one, you will make the groove with a positive value, and if you would like to make it with a negative value, you can make it like that. So it will be grooved inside the solid part with the defined value here, which is 1 millimeter. So that one will be grooved. So if you would like to make it warp like that, you can make the text warp to the surface by that way, but and as a groove. Now, if you would like to make it comes as extrude, you can make it like that. So if we, you can figure that it comes from the plane here up to the end, like that, with a different gradient values. So some texts you may find it as a grooved, and some surface you may find it with a positive value from the plane, like that. You can give it another color by giving it another color from here. So if we select black, for example, click OK. So the feature color will be on black, like that. Okay. So those are the available features for the Emboss feature. And now let's go to the next feature, which is split. Okay, let's open sample for split bar. Let's open this one. Here we have this solid, and we have a sketch here. And by using the split order, you will find 3 different options for splitting. If you would like to split the face only, you can select the rail, which is a split tool, that one, and select the face. With the first option, which is split face, you can split this face to different faces. That will give you ability to give that one a different color. For example, make that one as yellow, make that one as a red color. So you can make a different color for the same surface by splitting the face. So the first order gives you the ability to split the face. The next one, which is trim solid, that will make a cut, will remove a piece from the solid. Let's check that. If you select split, and by selecting the split tool and select the part or the feature, you can figure that this arrow gives you the ability to remove that one, or you can remove the top one like that. Okay, and by double clicking again, you can flip that to remove the bottom part instead of the top part. again by split and flipping the selection to remove the part. Okay. The third option for split, which is make two separate solids. Okay, so if you select this tool and select the feature, you will be able to separate that one to a separate solids. Here on the solid bodies, you can figure that you have two separate solids here, and you can give one of them property differ than the other, like that. You have two different solids inside the part. Okay, so here we discuss the available options for the split, which is a split surface, split part with a cut, which remove a piece, and from here split the part to different solids. Okay, now the second feature, which is a bend feature, which gives you the ability to bend parts. If we open that part like that, we need to make a sketch to define the bend center line. So we select this surface, for example, and make a line here. Okay, and click finish. Now you will find the bend feature here on the modify orders, so you can get bend from here. So when you select this line, you will be able to check that you have the ability to bend this part along that axis, and you will find the different ways to define this bend. You can change the bend radius. Let's make it 60 millimeters, for example, and make it 180 degrees, like that. So the bend will be like that. Defines the radius and the angle. Make it with that direction or the other direction, so you can make the flip from the right or the left, or in two sides, like that. Okay, that's the first bend. Bend on the left, bend on the right, or in two sides, bend and right. You can flip the direction, make it at top or at the bottom, like that. The first way to define it by defining the radius and angle. So here you have the ability to select, define the radius and angle. Another way to define it by defining the radius and arc angle. Here you can define the arc angle like 300 millimeters, and that's the radius, or you can increase this value as 400. So the arc length will be 400 millimeters. Okay, another way to define that by defining the arc length and angle. So you can define this angle as 180 degrees, and you can change the arc length. So those are the input data to define the bend part. By the way, the bend part, you can use it for common beds. If you have a common bed for two nozzles or something like that along the shell surface, you can use the bend order to make a bend for this part. Okay, now let's go to another feature, which is a mirror feature. Let's open a new sample. Okay, we have here a part, two features. The first feature, which is this bottom one. Another feature, which is that one. And if you would like to make a mirror for another feature, if you select a mirror and select this feature from the drawing area or from the tree, automatically you can figure that it's selected on the tree. And when you select the plane, you will get this feature like that. And you can figure it takes the same cut at the end here, because this surface is tilted. But if you would like to make it fitted, you can adjust that from here. If you open this extend menu and select adjust, when you click OK, it will adjust itself along the surface. Okay, Again, you can make a mirror along the original planes. If you have original planes here, you can make a mirror along the original planes like that. But if you have a defined plane, you can select it directly from here. Okay, I think now the most of commons of modeling, we covered it. Inshallah, on the third session, inshallah, we will discuss the remaining features and the sheet metal features. And now we will make some samples by using the features that we discuss them today. That's the first sample that we have, and we will proceed creating it, inshallah. Now let's create a new part. So from here, let's open part from the quick access toolbar, and let's think about this configuration, how we can start it. There are different ways to make it, and we will generate the same shape with a different ways. Okay, the first way, let's make this section, which is this L section, as a separate feature. So from here, let's make that one. And here we have the total height 38.1. So from here, let's make a rough sketch for that one, like that. .1, and the width is 38.1, the same. Yeah, so we can make it equal that value, and that value is 20.57. So 20.57, and that one is 12.7. 12.7. And that one 9.65. 9.65. And here the inside one is 19.05. So that one is 19.05. So that's the first solid we will make it. Okay, and the width of this one is 50.8. So let's click on Finish Sketch from top here, or from the shortcut menu, and let's make an extrude for this feature. And let's make it symmetric to the plane. Define this one as 50.8. So we will have the first feature here, which is that one, and let's click on OK. Okay, now we have this one here, like that. Now let's make the second one, which is this part, which is that one. So we need to create a new sketch, including this, and define the sketching here. So let's come back here and select this surface. Okay, so we will select the bottom surface here, that one, and create a new sketch. So by selecting this one, and from 2D sketch, you will be able to create a new sketch. Now we can use the geometry project to print this line here, to use it in our sketch. Here you can change the color of this line if you would like, because it's a yellow color. You may not, it will not be clear for you, so you can change it or change the property of this sketch, total sketch, from here by changing the property and change the color of this one to blue. Now it's appear here, and let's create this sketch. Let's make a roughly sketch. So we have a straight line, tilted line, and we have this one like that. Sorry, let's drag and move to make an arc, as we discussed on the previous session, and let's make that by that way. Now let's select those lines and make them equal. Select those lines and make them equal. Those lines and make them equal. Okay, now let's make this angle tilted by 45 degrees, and that one the same, 5 degrees. It's okay. Now let's define this length, which is 19.05. So the length here is 19.05. Okay, and the distance from the center to this edge is 15.8. So if we select the distance from here to there, it's 15.8. And the radius of the large circle, it's 11.18, which is that one. So, sorry. So we may have, okay, a constraint. So let's delete that one, delete that constraint. Okay, so this one is, okay, it's parallel to this and it's horizontal. So I think I make equal value for, so that one is parallel to that one. Okay, and so it's equal to, so let's delete this line and create another line here from here to there and find the radius of spacing between those as 11.8 times 2. Okay, and define the location of this one at the middle. So let's make those equal. Make those equal again. Make that one parallel to this one. Okay. Define the angle of that line, 5 degrees. Now we can make an arc connecting between those two lines. And by the way, we can make those lines equal, so they are equal. Okay, we can make this arc tangent to here and there, and define that as 8. Now we have this section or that part. You can make the inside circle. By the way, it's 12.7. That's the diameter. It's 12.7. So we have this sketch like that. Now, if we make an extrude for this one, select this surface, you will get that. You will need to define the thickness of that one. It's 11.10, so it's 11.10 like that. But it's not in that direction. It's on the other direction. So you will need to flip the direction of this one to get the that direction like that. Now we need to make the holes at the top. So we make two features. So the first feature was this one. The second feature was this one. And now let's make holes at the top. Let's add 2 points here and define the location of those holes. The spacing between them is 28.47. So spacing between them 8.47. And they are vertical. So when you select those, you can make them vertical. Now let's define the offset from the edge. It's 19.05. So from here to there, it's 0.05. So that's the location of the holes. If you click finish, now you will be able to create a hole by using those 2 sketches. And here that's the hole diameter is 12.7. So let's make it as a solid straight hole through hole and define the diameter of this one as 12.7. Now we have the solid 3D model of this part by that way, and you can figure that we generated by using extrude feature, another feature, and another hole. Okay, let's make the same part but by another steps. So let's save this part as sample 1. And let's create a new part. And here let's create a new sketch, and let's make the same configuration, but for all the cross section of this one. So let's make the complete side dimensions for this one. So it's like that. So the total height is 3.1. So from here to there is 3, and the width is 38.1. So 38.1. Okay. Here. Okay, and the height 20.57. And here the width 12.7. And 9.65. And 19.05. Okay. And the let's make this point above that one. So from vertical, let's select this point to make it vertical to that one. After that, let's define the length from here to there. It's 50.8 plus that value, which is 11. So 0.8 plus radius of this one, which is 11.19. So 10.19. So we have that one, and the thickness here it's 11.19. So now we have this cross section along that one. So we make all of that, and we will give it a thickness with 15.8. So from extrude, select that one and make it symmetric. 15.8. Now we have this sketch like this feature like that. Now we have the ability to make a cut here for those two pieces here. So let's make a cut. So by making a line here and there, the same we can make another 2 lines here and there. Make those lines equal, and select those lines and make them equal, and connect the end of this point to that line, the same for that line. Now let's define the tilting angle for that one. 5. For that one is 45. Define the distance 19.05. So from here to there it's, and the spacing between from here to there it's 11.8 times 2, 11.8, 18, 11.18, and 2, like that. So we have here, if we convert those lines to construction lines, we need to close those sketches. So we have 2 sketches here. We need to close them, and you can make one of them only and make a mirror. So you can. Now we need to cut those. So you can make a cut by using extrude. So you can select that one and that one and make it cut. So you can make a cut like that and make it through all the thickness. Or you can select one of them. So let's select one of them, make it cut through all. After that, you can use the mirror feature. So we can use this mirror feature and select one of the origin planes, which is the XY plane, to make a mirror for this feature. So we use some different orders here by making extrude build, extrude cut, after that making a mirror. Now we need to make a fillet here between those edges. Okay, As discussed, we have one order for the fillet here called round face, full round fillet through 3 faces. So if we select that one, when you select this face, that face, and the 3rd face from here, you will get this fillet like that. Okay, so let's click on OK. Now let's create a hole inside this one. So by selecting a hole and selecting this surface, you have a hole here, and you need to center it with that surface. So the first step, selecting a face. After that, selecting the surface and defining the diameter of this hole. After selecting the suitable type and behavior. Now, if you click OK, now you will get this hole like that. Now let's add 2 holes here, but let's make them by using the another option of holes, which is make it with offset distance. So let's define the offset distance. So the offset distance from this edge is 19.05. So it's from here it's 19.05, and from that edge it's equal to the let's calculate it. So it's 15.8 negative minus 28.45 divided by 2. So the offset here is 11.175. So 11.75. So that's the offset of this hole from that edge. So let's click OK. Now we have this hole on the right location. You can use mirror option to make another hole from this one. So you can select the feature from here, or select the same hole and select the XY plane for the mirror. So you can figure that we have, if we from view tab, if we make the arrange view as vertical views, we have the same parts with the same dimension, but they are created with a different trees. Okay, so this tree, including if we select this one, this tree including 1, 2, 3, 4, 5, 6, 7 features to make this one. But if you take a look at that one, you have 3 features only to generate this one, and you get the same result. So it depends up on you, how you will think to make this part, how you will build it using the available features of Autodesk Inventor. So we learn different features along this session, and we will try to use it on the next samples. So I'm trying to make a mix between features to give you the understanding of building a 3D part, after that making a modification on this part. Now let's save this sample. So let's save this one as sample 2. By the way, I will send, inshallah, after this session, those samples for you. Now, if we would like to create a drawing for this part, we will discuss the drawings in detail on the last session, inshallah, but I would like to give you a brief about that. So if we create a drawing here, okay, and let's select sample 1 and make the view as let's open the sample 1 only and make it not arranged. So let's switch to this one. Okay, now let's select a base view. By selecting a base view, you will be able to add a base view for a drawing or for a 3D model like that. So let's take a look from the top view for that part and make the scale 1:1. So it's top view. Let's this one appear. So keep the scale, keep everything here. And if you click on OK, you will be able to see that the hidden lines are now visible. Let's make scale 1. Increase it a little bit like that. Okay, so you can see that the visible lines and hidden lines they are appear on the drawing like that. No need to calculate it and check which lines are visible or which lines are hidden. So if we take another view from this one, you can figure that all hidden lines calculated automatically. And if you would like to make the lines without hidden lines, you can make it like that, so hidden lines will disappear. Or if you would like to make it with shaded color, so you will get the shaded color of this part. Okay, how we can change the material and the color of this part and get the center of gravity of this part. Okay, here, if we come back to this sample, you will find here on the quick access toolbar the material button. So from here you can select a material from the standard materials of Autodesk Inventor. And if you have your own library for materials, you can use it. But for example, if this piece as a steel piece, so if you select the steel, it will be like that, and the color of the material will be changed. You can change the color separately. So from this list, you can select one of those colors. It's a wood color, but let's make it with another color, like this yellow color. Okay, so we have this part with another color, but the mechanical properties of this part will be for a steel. So if you open this icon, which is a material property, you will get the material, this material, which is a steel material, and you can select another material from the list. But if you would like to make a modification on this material, like change the material name and some mechanical properties of this material, when you open the edit button from this pencil here, you will get this form, which is identify the material name. So you can make it as, let's say, steel 3, and change the as a material or wood or glass. That's the material description type. And for the appearance, the color of this material, how it will appear. And for the physical properties, and that's the important point here, which is the information of this material, the name of this material, and the description. And for the basic thermal properties like thermal conductivity, specific heat, that's in case of making a finite element calculation using a thermal properties for this material. And here that's the mechanical properties like the Young's modulus, Poisson's ratio, Kerr modulus, and the density. The density is very important to calculate the weight of this part. So if you change the density of this item, you will change the weight of the mass of this part. So for the default of the steel, you can figure that the density is 7.8 tons for cubic meter of this material. Okay, so after making your changes and changing the name of this material, by clicking on OK, you will change the name of this material. And now if you would like to calculate the weight of this material from the eye properties, you can get it from the quick access toolbar. If it's not appear in your side, from this arrow here on the quick access bar, you can add the eye properties icon to the quick bar. So you can add icons or orders to the quick access bar from this arrow here. If you open it, you can add the eye properties. Another way to get the eye properties from file, you will find eye properties. So you can open this form from here. From the eye properties, you can define some important fields like the title of this part, the subject, authored by, many other properties, and you can create custom properties for this part. And inshallah, we can discuss that on the fourth session. But for the physical properties, you can calculate the weight of this part. So if you get the physical properties and click on update, you will get the mass of this part in kilograms and the surface area in millimeters square, and that's the volume of this part. So if this volume, you make it times the specific gravity, you will get the weight of this part. Here the center of gravity, location in X, Y, and Z. And if you would like, here the inertia around the principal axis, the global and center of gravity. So that's the inertia properties. That's for if you will use this part in mechanical calculation, and you need to get the inertia properties for this cross section. Now, if you would like to make the center of gravity appear on the drawing area, here from the View tab, as we discussed, if you would like to make things appear or disappear like the toolbars, you can deal with it from the View tab. So from View tab, you will get the center of gravity button. So when you click on it, you will get this center of gravity of this part. So easily you can measure the distance from this plane, for example, to the bottom plane, or the distance from here to there, or the distance from, let's say, from here to that surface. So it's on the middle. So that's the location of the center of gravity. If you would like to make this center of gravity appear on the drawing, so let's modify that and make the hidden lines appear. Now it's shaded color with hidden lines. Now, if you would like to make the center line appear on this view, just select this one, and from the tree, you can right click and select center of gravity. So the center of gravity will appear here. You can measure it, or measure the location of this one from the start, from the bottom. So you can measure the location of this one here. And if you would like to make it appear here, you can select this view and make the center of gravity appear on this one. Because this part is symmetric, so the center of gravity will be symmetric from the two sides. Okay, now let's make another part. So let's close this. Okay, now let's create another part, which is that part. Okay, before going to that part, any questions regarding the previous features? Hello? Hello?
Yes, Mr. Ahmed.
Yes. Yes, go ahead.
Yeah, team. I don't know if team have any queries, or we have the question and answer session at the end of the session.
Okay, so let's keep the questions up to the end of the session.
Maybe the team can note down all their queries, and at the end of the session, we can raise the queries.
Okay, inshallah. Okay, now let's create a model for, or the 3D model for this part by different ways. So let's create a new part. So from here, let's create a new part. And if you take a look to this model, you can divide it in three main parts. If we take this cross section, make, let's zoom here like that, and take print screen. We can divide this as if we have a section, that section. If we draw this section and make extrude for that one, so we will get this feature. After that, we can make a sketch for this one. After that, we can make a circle or this cylindrical shape here. So let's start by that way. Okay, and let's check how we can make that. Okay, so from here, let's after creating a new part, let's create a sketch, and from here, let's make a roughly sketch for that. So make a line with 56 length. So it's with 56 length. Okay, and ridges here the length is 10. And the width here, 12. Okay, and this is 6 millimeters. So we have this one 6 millimeters, And now let's, I think they are equal, so we can select this line and that line and make them equal. Okay. Now we need to, this sketch is floating sketch, so we can get the center of this line to the center point like that. So we have this sketch here. Now if we click finish and make extrude, so the closed sketch will appear like that. So we need to make an extrude with 75 for this one and make it symmetric. So from here, let's make it 75, but make it symmetric to the origin plane and click on OK. Now we have this one. Now we have another cylindrical shape above here. This cylindrical shape from bottom to top with 63 millimeters. So from the top level of this circle to the bottom level, it's 63. So let's make a work plane. So select a work plane, and from here, let's select that surface and move up here and make 63 millimeters spacing with a negative value. So we will get this plane. Now select this plane and create a new sketch. So from here, create a new sketch. And now let's define the location of this hole. So let's make those two sketches like that. And from here, define the outside diameter of the outside circle, and the inside circle, it's 36, and the inside one is 22. And now you can figure that this circle is floating here. We need to define the location of this one. So let's make it in a horizontal position. So select the center and make it centered with the line. So now it's, you can not move it up and down, but forward and backward. So we need to define another dimension, which is 100 from the center. So select the center line to this edge. It's 100. Now we have, you can select, click on finish, or from the shortcut menu, select finish sketch or finish sketch from here. So now we have this circle on that plane. Now we need to make an extrude with a 25 millimeters. So from here, select extrude and select the surface. Here you can figure that we select the all solid, but we need to select the area between two circles, not both of them. So if you come near here, you will get the ability to select the areas or the long. For example, if you select both of them by wrong, you can, by control, and you keep clicking on control, you can select that to remove that one. And now you can define the extrude value to 25. So you will get the this shape like that. Now let's make that one invisible. And now we need to make a rep by that way for this solid. So how we can do that? Okay, you have some origin planes as we discussed. One of them is the YX plane, which is dividing this one to a symmetric sides. And we will use this plane to make this rep. So after selecting this plane, you can select a sketch, or select a sketch, after that select this plane. Now you have a way to draw this part. Now, if we make a slice graphs, this slice graphs order give you the ability to make a cut, draw the solids. So you will get a cut like that, so you can see the inside of the solid parts. And now let's select this one, this end, and make that line. And the end of that line from the center of this circle, it's 36. So we need to project a line here. So by using the project tool, we make a project for the line, and let's add a point at the middle. Now convert this one to a construction line and measure the distance from this one to that one as 36. So that value is 36 millimeters. Okay, and if you take a look to that line, it's moving up and down, and actually it's in the same level of that line. So by using the constraints order, which is collinear, you can make this line collinear with that one. Okay, now we have another line to the end, comes from here to the end. So let's create a new part from here to there. So let's make those lines along each other. So to make this point vertical with that one, so let's make it back like that. And from vertical, let's select this point and that point. So now they are in the same level. So if you move one of them like that, the second one will be on the same level. And if you connect between them with a line, this line will be a vertical line. Now, let's make one more thing, which is projecting some lines by using the project geometry. Let's project this line and that line, okay, to get a closed shape here. And let's convert those lines to construction lines. And for that sketch, let's change the color to blue, like that. So if you take a look from the 3D, you have this closed area here. Now, if we connect this point to the end point here, so to show you that this technique will not give you a good result, if we, which is connecting this point to the end here with a cylindrical shape, it will not give you the good result, But I would like to make it to show you how to edit that to get a good result. Here we connect this point at the end here, and let's make that the thickness of this part with 12 millimeters. So from Extrude, let's select this one and make it symmetric, and define the thickness with 12 millimeters. If you click OK, and figure that this one is not connected. It's not connected to the circle here. If you take a look from the top, it's not connected to the circle. So how to edit that? So during your sketching, don't weld this point to the end here. Get it inside a little bit, like that. So when you make give it a thickness, okay, and make it equal, like that, you will make it inside the solid, the other solid feature. So when you click OK, you will get that one by that way. One more thing here, you missed this point at the end of that one here. So you can figure that that end becomes not equal to or not on the same level of that one. So here we are facing an issue regarding the end point of this one. So how we can solve that? If we come back again to this model, we can solve this point by making this end with another straight end at here. So if we make straight end like that, and make this point in a horizontal level with that one. So let's make that one on the same level. So let's project a line here and make this point on the same level. So here you make a straight edge on that one. So if you connect this point to that end, so let's connect this point to the end here and make a straight edge like that. So when you make an extrude for that one, you will get a good result, which give you the ability that surface is matching with that one, and that surface matching with that one, and all area you have a welded area here, not without any gaps. So by that way, we make the 3D model without making a holes. So let's create a holes by the way of creating points. So let's select one of those surfaces and click on create sketch. And now let's add 2 points and make those points in a horizontal level. So let's make them like that. And now let's define the spacing between them, which is 45. So it's 45 from here to there. It's 45. And if we add a point to the center line, so the distance from here to there should be half this value. So we make a parametric relationship between the spacing of one hole to the other, so will be that value divided by 2. Now we need to define the offset, which is 28. So from here, let's select this one and find it as 28 and select all of that as a construction line. Now let's click finish. Now when you select a hole, you will find that you have 3 points and you don't need this one. So to remove it, select control button and remove this hole. So you have another 2 holes here. You can define the diameter of this hole, which is 12 millimeters, and click on OK. Now you have this hole and you have this 3D model of that part. Okay, you can add some fillets to this model. Here in this model, no fillets, but you can add some fillets, like adding a fillet on this edge and that one. Let's make it as a 5. Okay, adding a fillet for those sharp corners. So you can add fillets like that to this sharp corner, like that, to make it a little bit make sense. So by that way, you can we build this model. So let's save it. So save and so by that way we use the work plane to define this part. As you can see here, if you take a look to the tree of this part, and if you moved the end part after the extrude, so that's the first feature, and we used this sketch to create it like that. And here after that we create a work plane. So from the tree you can understand how this part created by checking the features of this part, so you can understand how this part created. Okay, so after that we create a work plane. So if you double click on it, you will get the value of the offset. After that we create this cylinder and we create this rib and holes and some fillets. Okay, so now we will go to another part. So in our samples we create this part by 2 different ways. Create that one, and now we will generate this type, or this part by 2 different ways. Okay, let's take a print screen, and here you can see we can make this cross section and make extrude for it. Okay, along here. Okay, so we will draw this cross section and give it an extrude. After that, we can select the back face and make this section, or this sketch here, which is for this rib. Okay, or we can make along the section here and there like that and make extrude. After that, make a cut here. So let's make the 2 ways to generate this part. So from here, let's create a new part. From parts, let's create a new part and create a new sketch. From here, let's define this one as 85 and the thickness is 18. So from here, 18 and 85. So here the width is 18 and 49. That's 18. And then if you measure this value, automatically you can get the result. It's 18 millimeter. Now the width of this one, we 3 millimeters, so that's it, 3 millimeters. Now let's click finish. Now we have this section, and now let's make an extrude with a value 140, this value. So let's make extrude. Automatically it will be selected 140, and let's make it symmetric around the origin planes like that, and click on OK. Now we have this one. So we have this solid. You can make the holes now, or you can keep it on another step. Now we need to make the back support, or the back rib here. So you can select this surface. So we can select this surface and create a new sketch. And by using the project tool, we can project this line to use it in our sketch. And if you take a look from the front view, we can start creating this one. So this line is, I think it's not vertical, it's an inclined line. So let's do like that, with an arc like that. After that, we have straight edge here with a fillet, and after that another straight edge with another fillet. So by selecting the end, and we can make that by that way. Okay, now let's make this circle tangent to that line, and that circle tangent to that line. Okay, now let's define the dimensions. So this the offset for the hole from the bottom, it's 56. So from here to there it's 56. Make this circle tangent to that line. Okay. And the offset of this hole, the diameter of this hole is 14. So the diameter is 14. So the radius, you can define it as a radius or as a diameter. So this diameter is 14, like that. And here the diameter of this circle is 55. So this circle is as a radius, so 55 divided by 2, like that. Or you can make it as a radius. So from dimension, you can make it as a radius. So it's 55, so like that. And the offset of this hole from that hole, it's 62. So from here, sorry, do and click F5. So from here it's 62. Offset from here to there. Okay, and the offset from this center line to this center line is 70. So if we measure this one from here to there, it's 70 millimeters. Okay, now we need to define this radius. It's 25. So this radius is 25 millimeters. Now you can figure that this sketch now is fully constrained. We have this sketch. Now you can add the holes on that sketch or make it as a separate holes, but let's make it here as the hole. So let's define the diameter of those holes. So from here, this one is 18 and that one is 30. So dimension 18 and 30, and click finish. Now we need to make an extrude for this one with 12 millimeters. So let's make extrude for this one with 12 millimeters. And you can figure that it's on the positive direction, but we need it on the other side. So let's flip the direction of extrude to make it on that side. So we have now this one. Okay. Now we need to make another extra pieces, one of them for this small one with 30 millimeters extrude from the end. So if we select this surface and create a new sketch, you can create or you can project this circle and create a new circle for the outside, and make this circle, by the way, you can make it located on that point, so automatically it will take the same diameter of the circle here. If you click finish, now you have this circle on with that like that, and you can make a separate extrude for this one. So the extrude of this value is 13 millimeters from the back plane, so it's 13 negative 12 or minus 12. So we can make an equation here. So it's 30 minus 12. So you can calculate the value of this one like that. So we make the first one here for this one, and let's make another feature for this circle here. The total extrude of this one is 63. Okay, so we have 60 millimeters on that side and have another extrude for that side, and on the middle we have 12. So we can do it by another way. Let's check that way how we can do it. So let's make a work plan with an offset with 6 millimeters here. So let's make a work plan with 6 millimeters offset. Okay, so we have the end plan here, and let's create a sketch on that plan like that, and let's make a project for this circle and that one. Okay, so we have not complete circle, we just project an arc, so you can draw your complete circle here like that. So, and click finish. Now if you try to make an extrude for this part and define the thickness of that one is 36, but you will make it with the negative direction. So you can figure that you make an extrude from here with 36 millimeters extrude from that one, like that. So we make it by using, or create it by using the another work plane to generate that. To make this work plane visible, just select it from the drawing area and select remove the checkbox for the visibility, or from the tree you can figure that it takes a orange color, so you can select it from here, right click and select the visibility. Now we generate that one, and we still have 2 holes here. So by the same way, you can select the surface and create sketch, add 2 points, make them vertical, define the spacing between them. So the spacing here is 70 millimeters. Okay, and if you would like to define the offset from this edge, is 35 and 30 from here. So it's 35, it's 30 from here and 35 there. And so if you measure the value from here to there, it should be the same. It's 35 and 35. Now let's click cancel, and let's make those lines as construction lines. Click finish. Now when you create a hole, you will be able to select those nodes and make the holes with 16 millimeters diameter. So we have this part like that. So let's save it as a sample 4, sorry. And you can figure that, as mentioned, the feature that created this part. So if you move the end part after the first feature, you can figure that we have this sketch. We used it to generate this feature, make it invisible. Now for the second feature, we make this one by using this sketch. So anytime if you would like to change the sketch, when you comes here and make a modification, for example, change this one to 15. Okay, so when you click finish, 3D model will change based on the changing on your sketch. Now let's make the other features. So each feature here will be stored on the tree. And anytime you would like to modify, just go to this one and modify it. Okay, now let's create this part by a different way. Let's create the same part with a different way, which is making a long cross section here. So let's create a part. So from here, create a sketch on that plane. Okay, and let's make a roughly sketch for the model. After that, we will add the dimensions. So here the height is 18, the total width is 85. So from here to there, it's 85. And that width is C. And it's 18. And the size of this one is 12. Okay. And the total height of this one, if we calculate it, we have 56 plus 62 plus the radius of the large circle. So let's calculate it. 56 plus 62 plus the radius of the large circle, which is 55 divided by 2. So we can make a bracket, 55 divided by 2. So you can make an equation like this. So that's the total height of this. Now let's click on Finish Sketch and make an extrude for all of that and make it symmetric. Define the width, which is 140 millimeters. Now we have this part like that, and we can make a cut on that one. So let's select the surface and let's draw the sketch that we will cut it. So let's make this one and make a straight line, another arc, another line, another arc, and like that. Now let's make this one tangent. This one tangent, it's already tangent, and that one I think it's tangent. Now let's define that. As you can see, this one should be tangent to the end because that's the highest point. So we can make those tangent like that, and define the diameter of this one. It's 55 divided by 2, and this one is 25. That one diameter is, I think it's 40. So the radius will be 20 millimeters, and the distance of from this center line to base is 56. So from here to there it's 56, and the spacing between that and that one is 62. So it's okay. So when you try to add it, it's automatically will be 62. It's a driven dimension because we already defined the height and defined the radius of this one. Okay, now let's define the spacing, which is 70 millimeters from here, from center to center. So from here, if you measure that one, it's 70 millimeters. And if you try to measure this one, it will automatically become 50. So it's a driven dimension. It's 50 millimeters. Okay, now let's add another holes here. So this one, it's, I think, 80. Let's say it's 80. And that one is 30 millimeters. So let's make it with 30 millimeters. Now let's make a closed sketches to make a cut for this part. Here, if you try to make an extrude, for example, here you can select the solid areas. So you can select those areas like that and make them as a cut, not a join part. So if you select a cut, you can make a cut for that one by that way. like that. So let's click OK. Now we have this part by that way. Okay, now let's make two work planes. One of them here with 6 millimeters, so 6 millimeters offset, and another one from this plane with 36 millimeters with a negative value because it's on the negative direction. So we have this plane here, and let's create a new sketch on this surface, so or in that plane. So let's select that plane and create a sketch, and from here let's project this circle, that arc, this circle, and that arc to use them on the model. So let's make the circle like that, and from here let's make extrude, but that time let's select that one only, and from here let's select 2. So by selecting extrude 2, we will make extrude to that surface. Okay, we want to use the same sketch because this sketch includes the another circle here. So we need to use the same sketch here. You can make this sketch as a shared sketch like that, or if you make it a visible, you can use it another time. So when you click on extrude, you can select this one, okay, and you can make it to that plane. So we use the feature of extrude with two different ways, which is from to or extrude to make the same shape. Okay, now let's make those planes and sketches invisible by selecting them like that. And finally, let's make the holes at that side. So we can make one hole. Let's make a one hole and make a mirror for this hole. So from holes, let's add a hole here and define the location, which is 35, I think. It's, sorry, it's a 30 and 35 from this edge. So it's, this one is 30, and from here it's 35. So let's click OK. Now we have this hole, and you can use mirror. So you can select this feature or select it from the tree. So select this one and make a mirror around the main plane, one of the origin planes, which is XY plane. So by that way, we create the same part. Let's save it as sample 5. So if we, from view, if we make them vertical views, so here we have the same parts. That one we generated. If we minimize this form, so collapse all parts, you can figure that we have 1, 2, 3, 4, 5 features with one work plane. Okay, but here if you select this one, make collapse children, we have 1, 2, 3, 4, 5, 6 features, and we have 2 work planes. We create 2 work planes. So as discussed, it depends on how you think to build or generate or create the 3D model for the same part. One more sample, we will do it inshallah, and in this sample we will discuss some other features and how to create different work planes. Now let's create this one, inshallah. I hope this sample give you a good idea about how to use the features to create the 3D model. Hello? Okay. Now let's create a new sample. Let's close those files and let's generate a new part. So if we take this one, here you can divide this part into two ways. If we make this cross section, which is this U channel or U cross section, and give it an extrude with that value, so we can draw this cross section and give it extrude. Okay, or we can make it by using sweep. So let's try sweep feature to make it, and instead of extrude, so to change or select another features. After that, we will make those two wings. After that, make a cut here and make this lug. Okay, so let's create a new part, and let's start creating a new sketch. So let's select this plan, and from here let's draw one of those the cross section here, which is the total width. Here we have 33, it's 66, so the total width here is 66. So here, so it's from here to there, it's 66. Sorry, minimize the font a little bit. Because the radius here is 33, so this value will be 66, and we have the spacing here is 26. So let's create a rectangle like that. So that's the cross section. The spacing from here to there is 26 divided by 2, and the total the distance from here to there 33. So this will be automatically as a 20 millimeters. So the length of this one is 60. So let's define this one as 60 millimeters, and we need to make it on the middle of the plane. So we can, by using a horizontal one, we can make we can align those points in horizontal position, and let's click on finish. Now we have this cross section, and if we select this plan, we can make a path for this one. So we need to project this line or that one. Okay, so we can project that one and make the inner contour of this shape, which is a U shape. So from here, let's select this one like that and make another one, and make this point vertical to the center. Okay, and let's define the height. Height is 70. Sorry, let's go inside the sketch again and define this 60 millimeters, and make this point at the same level of that point, like that. So we have that path and this cross section. So if you make extrude, sweep, and select that path, and with that one, you will get the same shape here. So by using the sweep order, we make a cross section and make a path, so you can get this feature like that. Now let's make another the wings. So the level of those wings on the same level of 70 millimeters. So let's make a work plane and start sketching this part. Now let's come here and get a work plane and make it with negative 20 millimeters, and click sketch, create a sketch. So you can figure that it's 70 or okay. So I think we need to modify that on the sketch. It's 60. So this value we need to change it to 70. So the work plane comes here. We can use it to make our sketch. So from here, select the plan on or sketch and from the tree. So you can get or make a slice graphs to make the contour of this one. Let's draw a rectangle like that and define the dimension. So the width of this one is 48, okay, and the total width is 144. So it's 48, so it's 48 millimeters. And from here to the center, to get it from the center, we need to draw a line to define the spacing from here to there. So we need to project this point and that point and connect between them. So we get that line, and by measuring it from the middle, so let's add a midpoint here and measure from here to there. It's 144 divided by 2. Okay, that's the end of this one. Now let's make this one. As you can see, it's floating, so you need to make it on the middle. So by using a horizontal option, let's select this midpoint and the midpoint here. So you can figure that this one now is not floating. So let's make this point vertical with the mid here like that, and click on finish. Now you have this sketch of this one. You can add the fillets inside the sketch, or you can make it as a separate feature. So let's make it as a solid like that, and make the extrude on the other direction. It's the default here. So let's flip it on to top, okay, and define the thickness of this one. It's 13. So find it as 13. After that, you can add fillets to that with the value here, which it's not appear here, or yes, it's 30. No. Okay, let's make it 12 millimeters. So you can make the fillet as a feature, so it's a separate feature, or you can make it on the sketch. So let's delete this feature and come back to the sketch again and add your fillets. So from here, let's add the fillet value. Select this corner and select that corner and click on finish sketch. Now you can figure that you make the fillet on the feature itself. No need to make a separate feature for the fillet. Let's make this plane visible. And now let's make the holes on this one. So the hole spacing is 30 millimeters, and the offset from the edge, it's the spacing is 106. So here, if we open this one, the spacing between holes, that's the spacing between holes, and here the spacing between holes. So let's select the surface and add 2 points and make those points as vertical points. Sorry, I click on the sketch to finish the sketch, but I should define the spacing, which is 10 millimeters. Yes, 30, and we would like to align it. So you can make a line and make this line as a construction line, and make the center point of this line aligned with center to make it centered with that line. After that, you will need to define the offset from the center line, so you can measure the distance from here to there, not there. We need to project this edge and that one and connect between them. Sorry, they are here, so let's connect between them. Or you can use the origin plane, which is on the middle, so you can project it directly. So if we remove that, and by using the project, you can project this line, so you will get this line, which is the midline. So you can use it directly to define the location, which is 100.106 divided by 2. That's so we get the correct position of the holes. Now, when you try to make a hole, automatically you will get the hole locations. Just you will need to define the hole diameter, which is 12, and through all to make it like that. Now you can make a mirror for this feature to the other side. So by using a mirror, let's select a mirror and select the features from here. So we can select that one and select the holes. But let's select that one as a separate feature and make it like that. You can figure that you make a mirror without the holes. So if you would like to include the holes, just double click on the mirror feature and select the feature by selecting a feature, and you can select the holes from tree or the holes from the drawing area. So by that way you create this solid like that. Now we need to make a cut here, after that creating a new hole through that one. So how to make a cut at the top here? You can make a plan at the top. So you can use one of the origin planes with like that one and make a tangent plane to that surface, as we discussed on the planes here. So you can make a tangent plane parallel to another plane. So here you can select that plane at the bottom and select the parallel plane at the top like that. Okay, or you can make the select the common or the original condition for the plane and create that plane by that way. Okay, or you can make this cut by using let's make it by that way first. Create that plan and make a sketch here. After that, create a rectangle like that and define the width, the dimensions of this cut, which is 26. So this one is 6, and the width of this one, the groove is 4 millimeters. So here you can make that one with let's make it with millimeters, for example, and click on finish. After that, you can make extrude with a negative as an extrude cut for this one with 4 millimeters. This is 4 millimeters like that. Okay, so let's increase the sketch dimensions a little bit. So let's make this millimeters and make a cut here, so you can get this shape like that. Let's make this plane visible, and you can make a hole on this surface. By another way, we can make the same cut. So if we make this feature suppressed, so let's suppress this feature, so you can figure that it's freezed. Now this feature is freezed, no cut here. We can use one of the origin planes, which is that plane, and create a new sketch. You can print or project this line and make a line with an offset with 4 millimeters from the midpoint here. So from here to there, it will be 4 millimeters, and you can make a cut, trim the line. So by using a trim, you can trim this extension and make an extrude. So if we make that and make extrude for this area, you can make extrude left and right with 6 millimeters. So you can make a cut here in that area, so it will give you the same result. Okay, now we can make a sketch here. So by selecting this surface, you can make a hole. So you can define the location of the hole by that way. So it will be located from here with 26 divided by 2, and located from here with a distance. You can measure it. So if you would like to measure it, so we can measure this distance. Okay, and copy this value, and when you come back to the hole, you can define this value to make it at the center. So with that value divided by 2, so it will come to the center directly. Now we make this shape by that way. Now we need to make the final part, which is this lug. So let's select the back face here and create a new sketch. So here let's create a new sketch and let's project that line And from here, let's create a roughly sketch like that and make a trim for this extend. Make this line tangent to that one and make this point vertical to that one. So it will be on the middle. Now we need to define that the radius of this one is 10 millimeters. So that will be 20 like that. And the center of this one, we need to check the height. So from the top, it's 123. So let's add a point at the middle. And let's measure the distance from here to there. It's 123. Like that. So we have this one. Let's add another circle to the inside. And the diameter of this hole is 12 millimeters. Now click finish. And let's make extrude. Select this closed sketch. Now you can figure that the extrude direction changed. You can move it to the other direction like that. And define the thickness of this one. It's 10 millimeters. So 10 millimeters. So we can get the 3D shape of this one. Let's save it. Okay, now we generate another sample by using the sweep feature. So instead of using the sweep, we can make this sketch and give it an extrude, but we try to use another shape, another feature. So we make a cross section and make a path like that for this one to make this section. After that, we create this wing including the fillets on the sketch itself. After that, making the holes, making a mirror for this wing and the holes, create a work plane and create this cut. After that, we freeze it so we can delete them. Okay. Here we make another way to make this cut by creating a sketch here with a depth of 4 millimeters. After that, we make a hole at the top like that. After that, we create the lifting lug at the end like that. So that's the steps to generate this part. As mentioned, you can make it by a different way by using another features, and you can get the same result. It depends on how you think to build the 3D model. Now let's go to the final sample, which is that one. And let's discuss how we can make it. It's a simple part, so you can. We have a section here and another section on the other direction. So let's create one of them. So from here, let's create a new part and create a sketch. So from a sketch, select drawing plane. After that, let's make this section. If we make a print screen here, this one, here for this one, let's start creating this sketch. So let's select the red color. So we will make this one by this sketch. Okay. So let's create this sketch. Okay, here. Let's create that one and give it an extrude with the total width, which is 62. So from here, let's get the dimensions. We have, let's make a roughly sketch and learn how to add dimensions after adding the roughly sketch. Okay. So let's connect this point with that point to make it as a closed shape. After that, let's add some dimensions. So the total height is 50 millimeters. So let's add 50 millimeters here. It's 12 and 6 and 38. So it's 12, 8, and 38. And that line should be equal to that one. So when you would like to make a constraint, automatically Autodesk Inventor give you this message, which is you will make over constraint because already this line according to your dimensions equal that one. Because if you sum 5 plus 38 and you have this total length is 50, you will get that one as 8 millimeters. So if you would like to get that one, and it's 7 millimeters, not 8, so it will be over constraint. So it's 6 millimeters, sorry, not 5. So it's 6 millimeters. So if you measure that one, you will get the same value, which is 6 millimeters. Now, if you try to move this one and that one, you would like to make those lines are in the same level. So by using linear constraint, you can make those lines in the same level, and we can connect this point to that point. So we can fix this face like that, and you can figure this. Those lines are still free, so you can make linear by using that, and the same for that on those two lines. So you can get the same result. Now let's define the spacing, which is the length of this one. It's 25 millimeters. But we have this radius. We have a circle or a ring here. So let's make the inner ring only, which is 14 millimeters. So from here we have this ring, which is 14 millimeters. Let's make this circle. So let's make that one, which is in. And finally, we need to define the distance between the center point and this one, which is 13 millimeters, this value. So from here, let's select the center point to this line, which is 13 millimeters. Now you can figure that the sketch become fixed. Let's click on Finish Sketch and make extrude right and left with the total width, which is 50 millimeters. Let's come back here. So for the 62 millimeters, it's from the rings here, but we will make it from here to there. So if we make a line, so we will make that width, which is 50 millimeters, not 62. So we make this extrude with 50 millimeters right and left. And we have this part like that, and we need to make a cut between those and make a ring on the outside thirds. So we can use the same sketch here, which is that sketch. So you can make it visible or share it to use it again. So if you click on Extrude, you can select this sketch and make it symmetric and make it cut and define the cut value, which is 26. We make a cut here with 26 millimeters. So we can make a cut with 26. So we will get that shape. Okay. So let's make this sketch invisible. And if you select that surface and create a new sketch, we can project this circle and you can draw another circle for the outer diameter of the ring. So we have this ring here with diameter 30 millimeters. So this circle diameter is 30 millimeters. Finish. Now you can make extrude for this circle and define the extrude value, which is should be 6 millimeters, because the total width is 62 here. The total width is 62. Here we have this 62, and that is 50. Okay, so the difference between them is 12 millimeters, 6 millimeters on each side. So the thickness here will be 6 millimeters. So we have this ring. You can make a mirror for this one by using the origin plane at the middle. So you can get that by that way. Now let's make the other feature on the other side, which is that one. So let's select the top plane here and create a new sketch. And from here, let's select or project that surface. So from here, let's project those lines and create this rectangle. So you select this type of rectangle. Okay. And convert this line to construction line. After that, take a look from the top view and make this section. Make this line tangent to that one. And don't forget to make this line aligned with this one, that one, to make all the time center. Now let's define the dimensions. So from this edge to the center is 25. So from here, there it's 25 millimeters. The outside diameter is 12.5. So the radius is 12.5. We have a hole here. The hole diameter is 18. So let's define that in millimeters and click finish. Now let's make an extrude. So let's make extrude 2. You can use 2 to define the end plane. So we can make it like that. Okay. You can see that it's make a cut, but you can make it as a join. So you can make a solid part like that. So you have a solid part now. We need to make a cut here on that area. So you can use a mid plane. Let's generate a mid plane by using a plane between 2 planes. So if you select that one and that one, you can generate a mid plane between them. Or you can use, if you using the origin planes as a default planes, which dividing your body and make it symmetric, you can use the origin planes directly. But in case if you don't think by that way, you can make a mid plane by using 2 surfaces like that. And from here, you can select this plane and create a new sketch. Now, if we make slice graphs and project those lines here and there and connect between those lines, we have a closed sketch here. So when you make extrude, you can make a symmetric cut, and the symmetric cut with that value, which is 26 millimeters. So it's 26. So you can make a cut. So be sure that you select a cut and make it symmetric. So by that way, you will get that one. Now we need to make a ring at the inside. Okay, so you can select this and create a ring. If you click on F7 or slice graphs, you can project this line and that one. You can make a circle, another circle, and make an extrude for this circle. So by using extrude, selecting this one, you can make an extrude with 6 millimeters. So the extrude for this one is 6 millimeters. And okay, now you can make a mirror for this feature around the mid plane that you create like that. Now you have this 3D model for this sample. You can draw it by many different ways and get the same final result. I think now we discuss the okay. Now I think we done this, and inshallah tomorrow we will discuss the sheet metal features and how to make a surface and add a thickness for this surface. And we will make some samples regarding the reinforced pads of the nozzles. We will make an assembly and discuss the assembly constraints, how to modify the physical properties, and I think we discussed this point, which is modifying the physical properties of the element and getting the center of gravity of it, how to make a parametric modeling and parametric assembly, the standard parts, and some samples for that. Inshallah, I will share this presentation with you after ending this session. As mentioned yesterday, I would like to receive a list of attendants with contact emails because I would like to receive the examples from the samples that I sent it yesterday with a 2D drawing to check if the attendants get the points which we discussed during the session or not. Because as mentioned, we will make some quizzes. So inshallah, I will share some other samples. You can make it today and share them with me tomorrow morning, inshallah, for the 2D sketch and 3D modeling. Now we can make an open discussion to discuss if you have any questions for the features and the modeling.
Team, any queries you have?